Welcome to the Copperfield Electric Podcast.
Glad to be here diving into this one.
Yeah, so today we are doing a deep dive on something that is literally right outside your bedroom window.
Hidden in plain sight, really.
Exactly.
Yeah.
Separated by just like an inch of drywall and stucco. There is enough raw, unmitigated electrical current waiting in your utility line to, well, basically power a small factory.
Oh, easily. Yeah.
And we just ignore it. I mean, we expect the lights to turn on when we flip a switch. We expect the fridge to keep humming. But very few of us actually stop to consider the sheer scale of that energy.
Right. Coming straight from the neighborhood grid.
Yeah. Or, the central hub attached to our exterior walls that safely bottlenecks and manages that massive, lethal flow of electricity.
Which is exactly our mission today.
Right. So we are exploring the unsung hero of your home's infrastructure, the meter main. We're going to look at how it keeps your house from catching fire, why modern tech is pushing older systems to the breaking point, and we'll briefly introduce the professionals at Copperfield Electric who actually handle this vital infrastructure across Southern California.
It really is the ultimate example of a system we just take for granted. We interact with the downstream results hundreds of times a day.
Right, plugging in phones, turning on the TV.
Exactly. But the gateway itself is entirely out of mind until something goes catastrophically wrong.
Yeah.
And understanding the meter main, it isn't just about technical trivia. It's really a masterclass in modern residential engineering. It's about how we safely translate that immense power into usable, regulated energy for your specific home.
Okay, so I want to start by throwing out some of the older, I guess, overly simplistic explanations of what this thing does.
Yeah.
I've heard people call the meter main a bouncer or an accountant for the house.
Right, I've heard those too.
But those metaphors, I don't know, they always felt a bit hollow to me. Because a bouncer makes a conscious, subjective decision, right?
Yeah, they choose who gets in.
Exactly. But electricity doesn't care. It just follows physics. So if we really want to understand what this gray box on the side of the house is doing, maybe we should compare it to municipal plumbing.
That is a much more accurate framework, honestly.
Oh, wait.
If you think about the utility lines running down your street as the massive municipal water main, the pressure inside that pipe is immense.
Like it would blow your pipes apart.
Exactly. If you tapped directly into it, it would blow the fixtures right off your sinks. So the meter main is essentially your home's primary pressure relief valve and volume tracker, all combined into one.
Okay, so let's break down the actual mechanisms inside that box then, because you basically have two primary components fused into one unit, right?
It's two main parts.
Versus the electrical meter, which is basically the utility company's cash register and just counts what you use.
Mm-hmm.
But sitting right next to it, sharing that exact same enclosure, are the main circuit breakers.
Yes, the brawn of the operation.
Right. So how do those actually work to stop an overload? Because, I mean, they aren't just digital sensors, are they?
Oh, not at all. They are entirely mechanical fail-safes. And the engineering inside them is just brilliant in its simplicity.
Okay, how so?
Well, inside that main breaker, you typically have something called a bimetallic strip.
Bimetallic? So two metals.
Literally two different types of metal sandwiched together. Now, when an electrical current flows through a metal, it generates heat.
Makes sense.
Under normal, safe loads, the heat is negligible. You'd never notice it. But if your home suddenly draws too much power, say a massive surge hits, or you plug in way too many heavy appliances at once.
The current spikes.
Right. The current spikes, and that little strip heats up dramatically.
And because it's made of two different metals, they react differently, like they expand at different rates.
Exactly that. As the temperature rises, one of the metals expands faster than the other.
Oh, wow.
Yeah, and that difference causes the entire strip to physically bend.
Just from the heat of the electricity.
Just from the heat. And when it bends far enough, it trips a spring-loaded latch.
Which snaps the connection.
Right, physically snapping the electrical connection apart and instantly stopping the flow of power.
That is fascinating.
It really is. It's a thermal failsafe. It doesn't rely on software. It doesn't need a microchip. It just relies on the immutable laws of thermodynamics.
Right, so if the wire gets too hot, the metal bends, the breaker trips.
And it prevents the wiring inside your drywall from melting and literally starting a fire.
Man, that is entirely reactionary physical protection. I love that.
It's foolproof.
So why are the meter the part tracking the usage for the bill and this main thermal failsafe combined into one single centralized unit? I mean, I imagine decades ago, These parts were probably scattered around the house.
Oh, they definitely were. You'd have a meter outside, maybe fiezes in a basement closet, and it was a complete logistical nightmare for emergency services.
No, I hadn't even thought about the fire department.
Yeah, so combining them into a meter main is a direct result of evolving building codes, because building codes are there to establish a baseline of absolute safety.
Right.
By forcing the meter and the main breaker into a single exterior enclosure, it creates this standardized, highly regulated gateway.
So the fire department always knows exactly where it is.
Exactly. Think about a crew responding to a house fire. They do not have time to run into a burning, smoke-filled basement trying to find the breaker box to cut the power.
No, of course not.
They need a single exterior point of truth where they can instantly kill all electricity to the entire structure before they start spraying water everywhere.
Right, because water and live wires, that's a deadly combination.
Exactly.
That makes perfect sense. It's about creating a universal language for safety. But, that brings up an interesting dilemma when we look at the reality of how we live today.
Oh, the modern demand.
Yeah. We've established the mechanics of this primary pressure valve. But what happens when the municipal water main stays the same, but we suddenly decide to install 10 new high-pressure showers inside the house?
That is the perfect analogy.
Because the baseline electrical demand of a home today has to be astronomically higher than it was in, say, 1995.
It is, and this is the exact logistical bottleneck we are seeing all across the country right now.
Let me play devil's advocate for a second, though.
Go for it.
If my lights are turning on fine and my TV works and my fridge is cold, why should I care about upgrading my meter main? If it's not broken, don't fix it, right?
Well, the problem is, it might be quietly breaking behind the scenes. A typical home built in the 1980s or 90s might have been built with a 100-amp electrical service.
Okay, 100 amps.
Back then, your highest draws were maybe an electric dryer, an oven, and the air conditioner.
And the rest was just incandescent light bulbs and a tube TV.
Exactly. But today, we are drastically increasing the load. More importantly, we are introducing what the industry calls continuous loads.
Continuous loads. Okay, that sounds like a crucial distinction. What is the difference between a normal load and a continuous load?
So think about your microwave.
Okay.
It draws a lot of power, maybe 1,500 watts, but it only runs for 2 or 3 minutes at a time.
Just enough to heat up some leftovers.
Right. The wiring inside your walls barely has time to get warm before the cycle ends and the metal cools back down. That is a peak load.
Okay, got it.
Now consider an electric vehicle charger, a level 2 charger installed in your garage.
Oh, yeah. Those pull a lot of juice.
They can pull 9,600 watts.
Yeah.
And they do it continuously for 8 to 10 hours straight every single night.
Oh, wow. So the system never really gets a chance to cool down.
Precisely. Under a continuous load, heat just builds up over hours.
And heat is the enemy.
Huge enemy. If your panel is outdated or the internal bus bars are even a little corroded, that sustained heat is exactly what melts older wires, degrades insulation, and ultimately starts fires.
That's terrifying.
It is. In fact, the National Electrical Code dictates that a circuit handling a continuous load can only be loaded to 80% of its maximum rating.
Just to give it a safety buffer.
Exactly.
Right.
Precisely to account for that thermal buildup.
So if I'm living in an older house and I decide to buy a new EV, or I want to put a massive solar array on my roof, am I basically looking at a ticking time bomb if I don't upgrade that central hub?
Well, it isn't a time bomb in the sense that it will instantly explode the second you plug your car in.
Right, okay.
But it is a severe systemic stress test that older equipment was just never designed to pass.
Makes sense.
Adding solar panels, for instance, completely changes the dynamic of power flow. You're pushing electricity backward through a system originally built for one-way traffic.
I never thought of it that way.
And adding an EV is essentially equivalent to plugging in an entire second house in your garage.
Wait, really? A whole second house?
In terms of power draw, absolutely. So if your breakers are tripping regularly, your system is crying out for help.
That bimetallic strip is working overtime.
Exactly. It means you are routinely drawing more power than the internal wiring can safely handle. And that physical fail-safe is doing its job by shutting things down.
Okay, let me stop you there, because whenever I hear the phrase electrical upgrade, my mind immediately jumps to total demolition.
Oh, people get very scared of the cost.
Yeah. Like, if I buy that EV and my 100-amp meter main can't handle the continuous load, does that mean I have to rip open the drywall in my kitchen and my living room and my bedrooms to completely rewire the entire property?
That is a very common and thankfully incorrect assumption.
Okay, phew.
The branch circuits, meaning the wires running inside your walls to your kitchen outlets or your bedroom lights, those usually stay entirely untouched.
Okay, so the upgrade is focused purely on the bottleneck.
Exactly. We're just widening the main pipe from the street.
Got it.
When a professional upgrades your meter main to a 200 amp or even a 400 amp service, they coordinate with the utility company to bring a thicker, higher capacity feed from the street to the side of your house.
So they replace the gray box outside.
Right. They install heavier duty main breakers, and then they can run a brand new, dedicated heavy gauge wire straight from that new panel directly to your garage for the EV charger.
Oh, that makes so much sense.
The rest of your house operates exactly as it did before. It just has a much larger, safer reservoir of power to draw from. It isolates all the heavy lifting to the central hub.
That is a massive relief. It isolates the disruption so you aren't tearing up your living room.
Exactly.
But, okay, knowing that the meter main is literally the front line between the lethal neighborhood grid and our living rooms, how do we monitor its health?
That's tricky.
Because this thing sits outside, right? Exposed to UV rays, rain, and fluctuating temperatures 365 days a year. I have to imagine the metal components degrade over time.
Oh, they absolutely do. We call it thermal cycling.
Thermal cycling.
Yeah. Over 20 or 30 years, the constant heating up during high electrical use and then cooling down at night causes the metal lugs and screws inside the panel to microscopically expand and contract.
Just constantly flexing.
Yes. And over decades, this can literally loosen the physical connections.
Which sounds bad.
It is. A loose electrical connection creates microscopic arcsing. Arcsing creates intense heat, and heat leads to total failure.
So wait, how do we actually catch that before it fails? Do we just, like, pop the front cover off and start tightening screws with a screwdriver?
Never. Under no circumstances should a homeowner ever open the meter socket or the main service enclosure.
Like, seriously, never.
The documentation is incredibly emphatic about this. It's a root canal of home maintenance. You would not perform your own root canal.
Fair point.
Before the electricity passes through that main thermal breaker we discussed, it has 0 safety limiters.
Oh.
The voltage entering the top of that meter socket is fully lethal.
Meaning if I bridge the wrong two pieces of metal with my screwdriver.
You don't even have to touch the metal.
Wait, what?
If you just drop a tool across the primary phases, it can trigger an arc flash.
An arc flash. What exactly is that?
It's when electrical current leaves its intended path and travels through the air to another conductor or to the ground.
It travels through the air.
Yes, the air itself becomes conductive plasma.
Oh my God.
It can produce an explosive blast of heat that reaches temperatures hotter than the surface of the sun.
You're kidding. Hotter than the sun.
Literally, in a fraction of a second. It will vaporize metal and cause catastrophic, life-threatening injuries.
Okay, that is genuinely terrifying. And I guess that perfectly explains why the utility companies mandate that only licensed professionals can break the safety seal on the meter.
Exactly. And another thing, the utility company owns the grid, and they essentially own the physical meter itself, even though you own the box it sits in.
Right.
If an amateur tampers with a meter socket, the utility company will often cut power to the home completely.
They'll just shut you off.
And they will refuse to turn it back on until the entire assembly is replaced and recertified by a licensed electrician and a municipal inspector.
So you definitely do not want to trigger a utility lockout.
It is a very expensive, very dark mistake to make.
Okay, so what is the proper protocol then?
Routine professional inspection. You get a licensed electrician who has the training and, very importantly, the insulated tools to safely open the enclosure.
Right.
They inspect the tension on the main lugs, look for signs of oxidation or moisture intrusion, and verify that the mechanical breakers haven't degraded.
So what should I be doing as the homeowner? Just leaving it alone?
The only maintenance a homeowner should ever perform is strictly environmental.
Okay, meaning what? Keep the bushes trimmed.
Precisely. Keep a 3-foot clearance around the panel. Don't stack firewood against it.
Don't hide it behind a trellis.
Right. Ensure that if a utility worker or a firefighter needs to access that box at 2 in the morning, they have a clear, unobstructed path.
That makes total sense. And honestly, this all really highlights the necessity of absolute trust in the contractors we hire.
Without a doubt.
If we are dealing with systems capable of vaporizing metal, you can't just hire a neighborhood handyman who watched a tutorial online.
No, you need professionals.
You need a team with deep institutional engineering knowledge. Which brings us to evaluating electrical providers, because we have some great info here on Copperfield Electric.
Yeah, they provide an excellent blueprint of the specific credentials and operational standards required to safely manage this kind of infrastructure.
So they're a family-owned operation serving Southern California, specifically focusing on Orange County, right?
Yes, that's their primary footprint.
And what stands out to me in the documentation isn't just their license number, which, by the way, is 1094740, fully verifiable, but their specific operational policies.
The policies are key.
They emphasize being bonded, insured, and mandating strict background checks for all their technicians.
Well, the background checks and insurance are non-negotiable baselines. You are granting these technicians access to the most dangerous system in your home.
Yeah, and often in private spaces like bedrooms or garages.
Right. And if something goes wrong during a panel swap, proper insurance ensures the homeowner isn't financially devastated.
So important.
But analytically, the most interesting part of their profile is their diagnostic philosophy.
Right. They state they will, quote, only diagnose a problem if it truly exists.
Yes. It's interesting that the sources explicitly highlight that specific phrase.
It implies a lot.
It strongly implies that phantom upselling is a systemic issue in the electrical contracting industry.
Phantom upselling, like making up problems.
Exactly. Because the inner workings of an electrical panel are largely a mystery to the average homeowner, it's very easy for a less scrupulous contractor to point at a harmless speck of rust and claim the entire $4,000 panel needs replacing immediately.
Wow. Yeah, if you don't know any better, you'd just pay it.
Copperfield's explicit refusal to invent problems points to a business model built on long-term trust rather than short-term fear-mongering.
And practically speaking, accurately troubleshooting a home, maybe finding out that a tripping breaker is just a faulty $30 mechanical part rather than a failing $3,000 panel that saves the homeowner an immense amount of money in the long run.
It does. They back this operational integrity with a 100% satisfaction guarantee. But more importantly, they offer 24/7 emergency support.
Which is absolutely vital, because catastrophic electrical failures don't respect standard business hours.
Never.
The breaker doesn't wait until like 10:00 a.m. on a Tuesday to fail. It happens at 2 a.m. on a Sunday when your HVAC system kicks into overdrive during a heat wave.
And when you're left in the dark, losing the food in your refrigerator and losing air conditioning, you need a team that operates on the reality of grid failures.
Not just a 9 to 5 schedule.
Exactly.
Their service footprint is extensive, too. Like, they cover major portions of the OC, from Irvine and Anaheim down through Santa Ana, Costa Mesa, Newport Beach, Tustin, Huntington Beach, Orange, Fullerton, Laguna Beach, all the way to Mission Viejo.
That's a massive coverage area.
It is. But what really solidifies their credibility, in my view, is the sheer scale of the work they handle.
Ah, you're referring to their commercial division.
Yes. Because we've spent this entire time talking about residential bottlenecks, upgrading a home for an EV charger, swapping out a degraded meter main, fixing safety outlets. But Copperfield doesn't stop at residential.
No, they handle massive commercial, high voltage and medium voltage services too.
Right. They design and wire schools, universities, medical facilities, and these sprawling warehouse distribution centers.
And that scale is deeply relevant, even to a homeowner.
Really? How so?
Because the fundamental physics of electricity remains the exact same, whether you are wiring a 1,000,000-square-foot warehouse or a 200-square-foot garage.
Right, the bimetallic strips still bend.
Exactly. But the regulatory complexity, the safety protocols, and the fault tolerances scale up exponentially in commercial work.
Ah, I see.
If a team has the institutional engineering capacity to safely manage a high-voltage commercial distribution center, retrofitting a residential meter main to accommodate a new solar array is well within their core competency.
It's basically a walk in the park for them.
Right. That commercial expertise directly informs the quality and safety of their residential capabilities.
It gives you a tremendous amount of confidence. So, just tracing our path today, we started by demystifying the gray box on the side of the house. We moved past the simple metaphors to understand the actual thermodynamics at play.
The physics of the failsafe.
Right. How a bimetallic strip bends under the heat of a continuous load to save your home from a fire. We explored how the shift toward 21st century green tech, like massive EV batteries, is fundamentally bottlenecking our 20th century residential plumbing.
Forcing those necessary upgrades to our primary pressure valves.
Exactly. We established why the lethal nature of incoming utility voltage makes DIY work an absolute impossibility.
Never risk an arc flash or a utility lockout.
Yes. And finally, we looked at Copperfield Electric as a prime example of the stringent licensing, honest diagnostic policies, and commercial-grade expertise required to safely manage the grid connection in SoCal.
It really highlights a critical intersection between our daily lives and the hidden engineering that makes it all possible. And, as we conclude, I think there's a broader philosophical shift happening here that is really worth considering.
No, what's that?
Well, the meter main, as we've discussed it today, is primarily a one-way gate. It takes power from the massive municipal grid and funnels it safely into your home.
Right, from the power plant straight to the television.
But the rapid adoption of solar panels and high-capacity electric vehicles is silently forcing a total structural transformation of this relationship.
Because we're generating power now.
Yes, we are no longer just consumers of electricity. We are becoming producers and storers of it.
That's true.
If you have solar panels generating energy on your roof and a massive EV battery sitting in your garage capable of storing days' worth of power, your home is slowly transforming into a self-sufficient microgrid.
That is a wild concept. The house essentially becomes its own miniature power plant.
Exactly, and the technology for bidirectional charging is already hitting the market.
Bidirectional, meaning the car powers the house.
Yes, it means your car could, in theory, power your house during a blackout, or even sell stored energy back to the municipal grid during peak demand hours.
Oh, wow.
As this bidirectional flow becomes the standard, the traditional meter main is going to have to evolve from a simple pressure relief valve into a highly sophisticated algorithmic energy router.
Like a smart traffic controller.
Precisely. The gray box of tomorrow won't just track what you use. It will autonomously decide when to buy power, when to store it, and when to sell it back. It fundamentally changes the relationship between the homeowner and the utility company forever.
Man, that changes everything. It means the hidden infrastructure we've been talking about won't just be a safety checkpoint. It's going to be an active financial trading hub operating right there on your exterior wall.
Right outside your bedroom window.
Unbelievable. Well, next time you flip a switch and that light instantly comes on, just take a second to appreciate the sheer mechanical genius of the thermal fail-safes keeping you safe today and the incredible microgrid technology that is waiting right around the corner. Thanks for taking this deep dive with us. Until next time.